All right, so in the previous video, we made a spline model of non-REM sleep as it accumulates across a 24-hour day in rodents. Um, and what we saw was that it didn't really seem like that the fit was all that great, okay? So again, the red line is representing the model prediction, and the dots represent the average of the data that was actually measured, okay? And we're not real happy with how poorly the model fits at different areas, okay? And so we're going to try something different. All right. And so what I'm going to try next is to borrow an idea from these basis splines, okay, and just apply something slightly different. So again, remember that with these basis splines, what we're doing is we're feeding the model these values, right, as though it was data that's being represented here by these kind of parabola-looking shapes. Not exactly parabolas, but similar. And then we're asking the model to tell us how much to increase or decrease the size of each of these shapes in order to fit the data best, okay? And so instead of using these kind of parabola-looking things, I'm going to use something different. I'm going to use a different set of basis values, okay? And what I'm going to use is, I'm going to recognize that sleep is expressed in kind of a cyclical pattern. And some of these cycles are 24 hours, that's a circadian rhythm, but then there are also shorter cycles, such as 12-hour rhythms and 6-hour rhythms and maybe even 3. And so in other words, there is cycles upon cycles that are kind of expressing themselves in sleep. Okay, and sleep is even more complicated than that when you get into the architecture of it. But to a better approximation, what I'm going to do is I'm going to try to model these cycles, and we can model cycles with sines and cosines, and I'm just going to use sines here. But I have a bunch of sine functions with different periods. Okay, and I'll show you what these look like here in a little bit. But we have a 24-hour sine wave, so it goes through a full period every 24 hours, every 12 hours, 6 hours, 3 hours, 90 minutes, 45 minutes, or I guess 30 minutes, and 15 minutes. I don't like that I did that. But anyway, it's fine for now. I'll probably change that afterwards. But nevertheless, so again, what I'm going to do, so now instead of having my basis splines where I was calling those B, now I just have these sines, okay? The sines, the values of the sines are taking the place of the B, the splines that we were using in Model 1, okay? And you see a very similar format here, right? So I have B24, so this is my coefficient, okay? And I'm going to have a different estimate for both groups times sine 24, a different coefficient multiplying sine 12, 6, 3, so on and so forth, okay? And again, you can look at these, you can look at the model in a little bit more depth, but again, it's very, very similar to what you've just seen in Model 1, but now using sine functions instead of the basis splines that we initially created. Okay, and so now when I run this again, I get my output. This is my posterior summary. Okay, and again, I have my coefficients for each of the different sine waves of different periods. Okay, but that doesn't help us very much. And so what we want to do is extract samples. Okay, so I have samples, and they're in this object, this list called post, and you can look at the different variables that are included so far. Okay, and then this is just more sine functions, but I'm going to need this when I start plotting. So that's all that is. I'm just recreating the values of sine 24, sine 12, etc. Okay. So just like in Model 1, I'm going to create an intercept that is dependent on time. So each value of time, how much sleep has accumulated as a linear function. Okay, and and now I am taking, this code gets a little bit convoluted, but now I'm taking every value in my sequence of sine 24 or sine 12 or sine 6 and so on and so forth, and multiplying it by the estimates for B24 or for B12, okay? Okay. And then I am, so I have all of that for group A as well as for group B. And now when I add each of these for each time point, right? So again, this will give me a bunch of values for each time point, okay? So now when I add all of these different sine functions together multiplied by their coefficient, I get the amount of non-REM sleep that is predicted during each hour. Okay, this will all be made clearer when we get to the figures, okay? And that's what's next here. So now I run my, now I'm going to plot all of this. So let's see what's happening. Okay, so this first one, this first figure is just our different sine waves at the different frequencies, right? This big one is going to be sine 24 for both groups, should be identical. And then I have one that looks a little bit less. So this first dotted one has a period of 12, and there will be one with 6 in there, and 3, and so on and so forth, okay? And so now, when at any one time point, I'm going to add up the contributions of each of these sine waves, okay? And that's going to be my prediction for the model. And so here's the prediction for that model, okay? And this is already fitting quite a bit better than the previous model. It's still missing some stuff here, okay? But altogether, this is a much better fit to the data. And in fact, if this was actual sleep data, it might fit much better. Remember, I made up this data, and so I'm missing a lot of things, and there's a lot of features of sleep that I am missing and probably accidentally implanting some features that aren't really features of sleep. But anyway, but I think that we can be happier then with this fit of the data. One more thing, and then that will be a wrap until the next topic. But we can also find what the average difference in sleep is from any two time points, right? So if I want to take hour 7 and hour 2, okay, so roughly from here to here, and I want to see how much more group 2 slept than group 1, I can use this bit of code here, and I'll get the average difference as well as the standard deviation of that difference, okay? This is called a contrast, but we get that it's about 116 minutes on average with a standard deviation of about 23 minutes. So in other words, Group B is sleeping on average 116 minutes more than Group A between hours 7 and 2, or 2 and 7, but that difference has a standard deviation of about 23 minutes. Okay, the next topic will be comparing these two models. This one certainly looks better by eye, but we will actually get a mathematically rigorous way of checking these two models against one another to try to determine which one do we like better. And then eventually we need to bring REM sleep into the fold, and we're going to do that in a very particular way that is not obvious given the models that you've seen already. Okay, but anyway, eventually those will come out. So that's it.